So we're going to be factoring by grouping. That's one method to factor. Next week we're going to be talking all about factoring. But I wanted to start with grouping because what we're going to do is we're going to take a polynomial. We're going to group it. We're going to do the first half of the polynomial and the second half. And we're going to use the greatest common factor like we've done recently. Okay? So let's start with the first two problems. They're just kind of introductions. It's just the first step. We're not going to factor completely. We're just going to do the first step and then talk about it for factoring by grouping. We're just going to find the greatest common factor of the first two terms and the greatest common factor of the second two terms. You ready? All right, so let's do number one together. So number one, if I can keep this straight, there we go. It says 2z cubed plus 6z squared. So what I'm going to do is I'm going to group the first two terms plus 3z plus 9. So then I'm going to group the second two terms. You ready? So now I've got 2z cubed. I'm going to write the prime factorization of this like we did last week. So 2z cubed, that's 2 times z times z times z. 6z squared, that's 2 times 3 is 6, right? And z squared is z times z. Where did I get what? You okay?
Oh, yeah.
Okay, okay. All right, then we're going to do the same thing with the second two terms. So then I've got 3z.
You want us to put like a little space?
Yeah, just like a little space. It doesn't have to be a big space, just a little space. That way you can kind of see like these are two different sets. And I'm going to color code them also. So 3z, that's just 3 times z, right? And 9 is 3 times 3. So let's do the first set. 2z cubed and 6z squared. What factors do those two terms have in common? 2's and then 2z's. So they have 2z squared in common, right? All right, so I'm going to write that. I'm going to start this down here at the bottom. I'm going to say 2z squared. And then what's left over? What's left over in that first term? Z. And what's left over in the second term? So plus 3. All right, we're going to do the same thing with the last two terms. What do 3z and 9 have in common? 3. So I can factor out a 3. So 3 is positive, so I'm going to say plus 3 times what's left over? Z plus 3. That's it. All right, I want you to do the same thing with number 2. I want you to try it. So we're listing the prime factors of each term, just like we were doing last week. And then find what the first two terms have in common and what the second two terms have in common. All right, so I'm going to start by listing the prime factors of all 4 terms. So 2r cubed, well, that one's easy. 2 is prime, so we've got 2 times r times r times r, right?
Oh, ours is 3r. It's 3.
Oh, sorry. I knew that, and I forgot to change it. Easy for me to fix. So that's a 3. Three. There we go. Sorry about that. All right, then 12r squared. 12, the factors of 12, that's 2, goes in 6, 2 goes into 6 3 times. So that's 2 times 2 times 3 times r, right?
Yes.
So far, so good?
Yes.
Is that okay? Okay. Negative 5 is negative 1 times 5. And we have times r, right? Negative 30, well, I know that's going to be negative 1 times, well, what goes into 30? 2 goes into 30 15 times. 3 goes into 15 5 times, so that's 2 times 3 times 5. Oh, not at all. If I can find where I put them. Yes, sir.
I know how you got the on the 2 on the 12. I know how you got the 2
Uh-huh.
and the 2 and the 3, but
Uh-huh.
I don't know how you got the double R.
R squared is r times r.
Oh yeah.
Good question. Thank you for that. Very good question. All right, so now in the first two terms, I want to see what do we have in common?
3
And
and r squared.
r squared, right? So we have 3r squared times, what's left over?
2 plus
R plus,
2,
well, what's 2 times 2?
4.
4. So r plus 4 is left over. Is that okay?
Yep.
All right, now let's do the second two terms. What do I have in common in the second two terms? 5. What about negative 1? Ooh. So I've got negative 5 times r plus 6.
What'd you get plus 4?
Plus 4, because 2 times 2 is 4.
Wait, how'd you get 6? Because 2 times 3. Oh, yeah.
Uh-huh. 2 times 3 is 6. That's how I got that 6. 2 times 2 is 4. That's how I got that 4. Good questions. Good questions. So we're going to put whatever's left over back inside the parentheses, right? All right.
That's right too.
So that's your answer. So, well, I want to look at these two examples just real quick. I notice here in the first example that binomial, what was left over was the same, right? Hey, that looks an awful lot like distribution, doesn't it? Right? So if your binomials are the same, we can actually take this a step further and factor. If these binomials are the same, so for example, in number 1, z plus 3 is a factor. So I'm going to go ahead and write that. Z plus 3 is one of my factors. My other factor is going to be 2z squared plus 3. All that is distribution backwards, right? Because remember when we were multiplying binomials, we said the first term times the other binomial, and the second term times the other binomial, right? So if we have the same binomial, we can rewrite it. That's one of the factors.
Well, wouldn't you have to put an exponent of 2 over the z plus 3?
Ooh, no, because that's how the distribution works. Remember, we were taking that first term times the second binomial, the second term times the second binomial. Exactly. But here in the second example, are my two binomials the same? No, so that's as far as we could factor. That's it. Huh? Binomial, r plus 4 is a binomial because it has 2 terms. R plus 6 is a binomial because it has 2 terms. All right, so let's take number 3 a step further and see if we can factor it completely using grouping. We're going to factor by grouping. You ready? All right. I'm going to ignore that no and keep going. Woohoo! All right. So, the idea is we're going to group the first two, group the last 2 terms. So I have 14y cubed. 14 is 7 times 2. And then y cubed is y times y times y. All right. 8y squared. 8 is
2 times 4.
2, and 4 is 2 times 2, right? Okay. Is that okay? All right. And then y squared is y times y. All right. My next binomial, or my next pair, I should say. It's not a binomial because it's part of the whole polynomial. 7y plus 4, so I've got 7y. Well, that's easy. 7's prime, so we have 7 times y, right? 4 is 2 times 2. All right. So let's see. What do my first two terms have in common?
2.
2
And 2y.
and 2y. So we have 2y squared in common, right? So I can write 2y squared times what's left over?
7
7.
times
Oh, wait. 7.
plus 4.
7. Y.
Oh, yeah.
Caitlin, you're exactly right. Plus 4. Beautiful. Thank you for that, dear. It's 2 times 2 is 4. Perfect. Scooch that up just a bit. There we go. All right. And then in my second two terms, what do I have in common? Ooh, nothing. But I'm going to point out, I could say times 1 and times 1, and that's the same thing, right? So technically, they have times 1 in common, right? Because we have to have something to factor out.
So it has to have something.
Mm-hmm. So I can factor out a 1. And then what's left over? 7y. Oh, good. Because now I can say my binomials are the same, right? So one of my factors, 7y plus 4. We'll scoot this up so y'all can see. 7y plus 4. And what's my other factor? 2y squared plus 1. Yes, because this is factoring by grouping. This is your answer. You got this. It's a cake. No, it doesn't kill you. All right. Number 4. Let's take a look at 4. Y'all ready? Woo! Number 4. We've got 20v cubed plus 25v squared. You okay, hon? All right. And then I have negative 25v minus 30. All right, what goes into 20? 2 times 2 times 5, right? And then v cubed, v times v times v. It's a beautiful prime factorization. All right, 25. Oh, that one was easy. 5 times 5. Wait. V squared, so we got just 2 of them. Good job. Good job. All right. Negative 25v. Negative 1 times 5 times 5, and then we have it times v. Negative 30, I've got negative 1 times 2 times... Wait. 30 That's 15, right? What goes into 15? 5, 3 times, right? There we go. It doesn't matter the order, does it? No. All right. So now, what do your first two terms have in common? 5 and v squared. Beautiful. So we have 5v squared. And what's left over? 4v. Perfect. Very nice. You've got this. And then the last two terms? -1 and 5. So that's -5, right? And what's left over?
Wait, we don't count the -1?
No, we did because that's -5, right? -1 times 5 is -5. Good job, good eye. 5 plus 5v plus 2 times 3 is 6. So now I'm going to look. Are those the same binomial? No. So can I factor any further? Nope. This is your answer. That's it. No. As with most things, the more we practice, the easier it is, right? All right. There's always a back. Well, usually. All right, number 5. I want you guys to try 5 on your own. So the first thing we want to do is I'm going to list the factors for the first two terms, list the factors for the second two terms, right? So we've got 12y cubed. So, well, we just did 12 recently, right? So I know that's 2 times 2 times 3 times y times y times y, right? 4y squared. 4 is 2 times 2. Y squared is y times y. That's not so bad, right? And I've got -9y. That's -1 times 3 times 3. I saw lots of people get that. Nicely done. And then -3. That's -1 times 3. So far, so good? Everyone was okay with the factoring? We're getting better at that. All right. So the first two terms, what do the first two terms have in common? 2, 2, and then 2. You see it now? And 2y. So 2 times 2 times y is 4y squared, because 2 times 2 is 4. Very good. All right, this was the tricky part. What's left? So I have 3y left in the first term. Is there anything left in +1? Because if I left that as 0, that would be like having a times 0 here, but that would make this whole thing 0, right? But if I had a times 1, that doesn't change anything, right? So I can bring down that leftover 1. Is that okay? Okay, good. All right, let's do the second two terms. I've got, they both have a -1, and they both have 3. Beautiful. So I can factor out -3, and what's left? 3y.
Times 1.
Uh-huh. So that I can have that +1. So now, we'll scoot this up just a smidge. Now, do I have,
3y plus 1.
I have a matching pair of binomials, so 3y plus 1 is one of my factors. What is my other factor?
4y squared -3.
That's it. Air 5. All right. Number 6. Do y'all want to try 6 and we check it together?
Yeah.
All right. All right. So let's start out with the first two terms. Let me zoom in here so I can write a little better. All right. So I've got 8p cubed minus 32p squared and 28p minus 112, right? So 8p cubed. Xavier, can you help me with that one? Because I saw you got it. What's 8 factored?
2 times 2 times.
Beautiful job. And then p cubed is, you've got this. All right, negative 32p squared. We're going to start out with negative 1. And if we divide 32 by 2, what do we get? 2 times 2 times 8. But then what's 8? 2 times 2 times 2, right? So we want the prime factorization, right? Times p times p. All right, let's pause here and do the pledge. All right, so let's pick back up. 28p, 28, that's 2 times 7 times p. Negative 112 times there we go. See, 2 times 2 is 4. 4 times 2 is 8. You got how many 2s? I was about to say, because we need one more. Yep. There we go. All right, so now what do the first 2 terms have in common? 1, 2, 3 2s. 1, 2 p's. So 2 times 2 times 2 is 8. You got it, you're okay. P squared. And then what's left over? P. Well, negative 1 times 2 times 2 is negative 4. Right? All right. Now my second 2. 2, 2, 7. Well, that's it, right? So 2 times 2 times 7 is 28 times what's left over? P minus 4, right? So now can I factor that further?
Yes.
Yes. So we've got a matching binomial, so p minus 4 is one factor. And then I've got 8p squared plus 28. All right. 7 and 8 are for you to practice. I want y'all to do those now. We've got some time now before the bell. 9 and 10, we're going to omit those for the time being. We're going to pick back up and be able to do those later next week. But for now, I want you to practice 7 and 8. 7 and 8.